it's your favorite NPC, and today I'll teach you everything you need to know about HTML Canvas. We learn what Canvas is, how to set it up, draw shapes on it, animate those shapes, and then add gravity so things actually fall. So let's get started, guys. HTML Canvas is an HTML element that lets you draw and render graphics directly in the browser using JavaScript. It's mainly used for visuals like animations, games, and particle effects. If you want to create modern websites that include particle effects, for example, you could use HTML Canvas for that. To get started using the canvas, we of course need to use HTML and JavaScript. And in order to write HTML and JavaScript, we could use a code editor. And I'm going to use VS Code in this course, so feel free to use VS Code as well, but you can also use another editor. To get started, we should first create a new project. So let's go here, open folder, and now we should create a new folder for our project. I'm going to create this folder on my desktop, so I'll go to desktop. I'm going to right click right here, new folder, and this will have the name canvas-course, for example. I select this folder, and this will be the folder for my project. In order to create a canvas, we should now create an index.html file, like so. And let's also start by creating a basic template. Now that we've got this template, we can open our HTML page using the live server. So right click, open with live server, and this should open your page right here. And in case you don't have the live server yet, you can just go over to extensions right here, search for live server. This is the live server, so click the live server and you can just press install right here. And the benefit of using the live server is that we can now enter something on our HTML page, like hello for example, and this will automatically update our web page, as you can see. But now let's get started by using our canvas. And to use an HTML canvas, we can just use the canvas element like so. And this will create our canvas. But at the moment we're not able to see the canvas. So let's use a style shield in order to do so. So let's create a style.css file. And let's start by linking the style sheet to our HTML page. So link :CSS to link our style shield. And now let's target our canvas. Let's use an ID, for example. ID could be canvas. And now let's target #canvas inside of CSS. And let's use a border of 1 pixel solid black. And as you can see, this right here is our canvas. Let me also reset all of the HTML styles, so all of the base styles, by using the universal selector, like so, margin 0, padding 0, and box sizing of border box, like so. So this will just reset the styles that our browser applies by default. But now this here is not that important. Let's start by using JavaScript. So let's create an index.js file, and let's link this index.js file within our index.html file. So right here, let's use a script :source tag to link our index.js file. And right here, we also need to use the defer attribute that tells our browser to pass this JavaScript file after all of the HTML code has been parsed. And now let's get a reference to our canvas within our index.js file. So const canvas is going to be equal to document get element by ID, and the ID name was canvas, because of course the ID I used right here is canvas. So now we only have the reference though. Let's also define a width and a height for our canvas. And just remember that it's important that you use JavaScript to define the width and the height of the canvas instead of CSS. So now we can just say canvas.width is going to be equal to our window.inner width, like so. And you can see now the canvas spans the entire page. So the entire width essentially. Now for canvas.height, we could say we want to have window.inner height, for example. And now I can see the canvas also spans the entire height of our window. But this right here is not necessary. You could of course also define a certain width of maybe 200 and a certain height of maybe 500. So that is up to you. But oftentimes you just use window.innerWidth and window.innerHeight to span the entire width and height. Now let me also remove the border because that one doesn't look too good at this point. And let me just use a background for our canvas of maybe black. Doesn't matter too much for now. You can see this here is also looking a little bit weird. We are having those weird scroll bars, but let's get rid of them by defining for our body an overflow of hidden, for example, like this. And you can see now this looks pretty nice. So now this here is essentially our canvas. So this here is our canvas that spans the entire page. And now we can draw something on our canvas. So we can draw rectangles, circles, and so on. But first of all, in order to draw something, we need to create an object, a context object. So I can say that a variable const, and the name is up to you. I like to call it ctx for context. This is going to be equal to canvas.getContext, like so. And now we could, for example, create a 2D context. So 2D right here. And all this line here is saying is that we want to create a context object, and this context object can be used to use a lot of different methods to draw stuff on the screen. So essentially, canvas.getContext just returns a lot of 2D specific methods to draw onto the canvas. And let me start by showing you the first one. The first one could be used to create a rectangle, for example. So we'll access ctx, which provides a lot of different methods to draw onto our canvas. And now we could, for example, use fill rect for fill a rectangle. And you can see we need to insert a couple of different values. An x value, a y value, a width, and a height. So let me first of all enter all of those numbers and then I'll explain them to you. So maybe we can say 100, 200, w could be 50, and height could be 50, like so. So I'm going to save this. And at the moment we are not seeing anything because we're drawing black on black. So if I'm going to remove for hashtag canvas the background, you can see that we now have this rectangle right here, but the color is black. So we could also just change the color of our rectangle by saying ctx.fill style being equal to, and now we can define a color right here. This could be white, for example. And you can see the rectangle is now white. But this here could also be an RGB value, so RGB, or an RGBA value. So RGB 255, 255, 255, which is of course equal to white, would be valid as well. And you could also use RGBA of 255, 255, 255, 0.4, for example, and this is valid as well. And you could also use a hash code. So maybe hashtag FFF, like so, which would also be white. So I can just use normal color codes essentially. Now let me also explain how this here works. So the first value right here is our x value. Our x value defines the distance on our x-axis. So it essentially defines the space from here, so from the left, to our rectangle. The second value is our y value. That one defines the distance from the top of our page to our rectangle. So essentially that one defines this one right here. So this is x and this is y. The third value defines the width of our rectangle. So essentially it defines the width of the square. And the last value defines the height. So essentially that one right here. So those are all of the values. Now let me also create a second rectangle. So let me say ctx.fill rect. And let's say this here is a little more to the right. So let's say 200, 200, 50, 50, for example. And you can see now we have a second rectangle right here. And you can see ctx.fillStyle also applies to the second rectangle. If we wanted to change the color of our second rectangle though, then we could change ctx.fillStyle right before creating it. So this ctx.fillStyle applies to all of the upcoming elements essentially, unless we state otherwise. So if we right here say ctx.fillStyle is going to be equal to yellow, for example, then up to this point, all of the elements will have the fill style white, and from this point on, all of the elements will have the fill style yellow. So you see this one is now yellow, and all of the other ones would also be yellow. So 300, for example, would be yellow, 400 as well. So this is how this works. But now we could also define a shadow. So we could say ctx.shadow blur, for example. And this is going to be equal to 20, for example. So 20 pixels. And you can see that we are not seeing anything. And the reason for this is that our shadow color is black at the moment. So let me also change the shadow color. So ctx.shadow color is equal to yellow, for example, as well. And now you can see that we have our shadow right here. And now if I change the shadow blur, you can see that the strength of our shadow essentially changes. So 40 and so on. So all of those properties start to apply from the line where you essentially defined it. So ctx.shadowBlur will affect all of the upcoming elements right here. ctx.shadowColor will affect all of the elements right here, and so on. So I think you get the idea. And that is how you create a rectangle using Canvas. But now there exist a lot more elements. So let me show you a couple of them. And something that you want to use pretty often is a line, for example. So let's create a line. In order to create a line, we first of all want to begin a path. So we use ctx.begin path, like so. So this says begin a new path. Now to define the starting point of a line, we use ctx.move to, for example. And right here we have to enter an x value and a y value. And that x and y value defines the starting point of our line. So if we enter 100 for x, this means move 100 pixels on the x-axis, and the same of course for y. So 100 on y would mean move 100 pixels on the y-axis. So let's use 100 and 100 for example. Now we could also define an ending point. So ctx dot, to define the ending point, let's use line 2. And let's for example say 200, 100. So we'll only move on the x-axis. So essentially we'll probably start around here, 100, 100, and we'll move to 200, 100. So over here. But now we are not able to see our line. So let me use ctx.stroke. So this will now draw our line. But again, we are not able to see the line because our background is black. So this here is the line. But of course, we can also change the color of our line by just using right here, for example, ctx dot, and previously for a rectangle, we used fill style. But for a line, we have to use stroke style, like so. And our stroke style is going to be white, for example. And of course, this should be stroke style, like so. But now it's also possible to extend this line. So we could, for example, say ctx dot line 2. And let's, for example, say now we want to go down. So we'll stay at x 200, but we'll move a little bit further down. So we'll increase our y value to 200. Now let's also try to move to the left again. So we can just say ctx dot line 2. We need to decrease our x value, so 100, and y will be 200, like so. And of course, to create a rectangle now, we could just say ctx dot line 2, and we need to go back to our initial value, so 100, 100. And this would be a rectangle essentially. So this is how you essentially create a line. You could also create another line by saying ctx.begin path once again. Let's say ctx.move to, let's start at 200, 500 for example. And let's say ctx.line 2, let's go to 200, 700. And let's just use ctx.stroke, like so. So now this created another line, or a new line. And you can create a lot of cool stuff using that, but feel free to experiment a little bit with that. And of course, again, if you wanted to change the color for our second line, you could just use ctx.stroke style of yellow, for example. And from that point on, everything would have a yellow stroke style. Of course, shadow blur would work as well. So ctx.shadow blur of 20, for example, and ctx.shadow color of yellow, like so. And now we will also have a blur. And maybe 20 is a little bit too much, so let's use 5. And you can see we have a slight blur right here. Now let's also try to create a circle, for example. And in order to create a circle, we should again use a path. So ctx.begin path once again, like so. Let's also define a color. Let's say white. So ctx.stroke style is going to be equal to white, like so. And now to define our circle, we have to use ctx.arc. So to sum up again, fill rect to create a rectangle, move to combined with line to for a line, and ctx.arc for a circle. So you see the syntax is pretty similar for all of those elements. And you can already see we need a lot of different elements for our circle. So the first one is x, then we have y. So this is the offset on our x and our y axis again. Then we have a radius for our circle. We have a starting angle, an ending angle, and counterclockwise. So whether the circle should be drawn counterclockwise or not. And this is a lot easier than it looks like. So for the x value, we could again use an offset of 100 and 100, like so. A radius of 50, for example. If you want to create a full circle, you should usually start at 0 degrees for the start angle. And to get a full circle for the end angle, you will usually use 2 times math.pi pi, like so. Now we also need to define counterclockwise, and this is going to be false, because this doesn't really matter for us. And now let's use ctx.stroke, so we can see our circle. And again, this here should be stroke style, of course. So now we are seeing our circle. So again, this here's the starting angle, and this here's the ending angle. And to get a full circle of 360 degrees, we need to say 2 times math.pi. So to only get half of it, we could just say math.pi, like so. So as a starting angle, we could of course also define something else. So we could also as a starting angle define math.pi, for example, like so. And as the ending angle, 2 times math.pi. So that is up to you. And of course you could also say 1/4 and so on. So you get the idea. But usually you want to have a full circle, so you just use 0 and 2 times math.pi. Again, you could also fill a circle, so I could also say ctx.fill style is going to be equal to white. And now we can also fill our circle, so we can use ctx.fill followed by those brackets, and now we filled our circle. So that is possible as well. We could also use a different color, so we could say this here is going to be yellow, and the stroke is going to be white. And now we can also define the thickness of our line, so of our border, by using ctx.line width being equal to 5, for example. And you can see now we have a thicker line. This could also be 10, that's up to you. But you already see you can create a lot of cool effects by doing so. So I could also just say the radius is 20, for example, or 10, maybe a little less stroke. And if you would now have a lot of those circles, I think this could already look pretty cool. So there exist a lot of different shapes, but I think those ones are the most important ones, and you'll probably most of the times use only them. So now I want to introduce you to a very important concept, and that is the concept of classes. Of course you could create a circle like this one, the way we did it up to this point, but there's also a much better way, and especially a way that we'll need a lot later on. And that one is a class. So we could just say we want to create a class of circle, for example, like so. And now we could create a constructor to construct a circle essentially, like so. That one accepts a couple of parameters, and we need to initialize that one. So this is just a normal JavaScript constructor essentially. And this constructor will be called to create objects of the circle class. So later on, we can use this class blueprint to create as many objects as we like. So this blueprint here defines how every single circle should be, and then we can create different circles. So circle 1, circle 2, circle 3, and so on. And every single circle can now have a different radius, a different x position, a different y position, a different color, and so on. So I think you get the idea. And when using the constructor, we define all of those properties. So all of those properties that should be different for every single circle. And the first one is of course probably our x value and our y value. Maybe every single circle should also have a different radius and maybe also a different color, like so. Now, since this is not a JavaScript course, I'll not explain this too much, but we are just going to say that this.x is going to be x, this.y is going to be y, this.r is going to be r, and this.color is going to be color. So this refers to the object that we're later on creating by using this circle constructor. And those individual values just refer to the parameters that will pass to every single circle object. So let me show you. Let's create a circle 1, for example. That one is going to be equal to new circle. So we create a new circle. And now for that circle, we could use x position of 100, y position of 200, radius of 20, and color of white, for example. So that is totally valid. And now we could also have a second circle, so const circle 2 is equal to new circle. That one will sit at position 200, 400, radius will be 50, for example, and color will be yellow, like so. And you can see we already created 2 different circles. We are not able to see those circles yet, but those circles have different properties. And this always refers to the object that has been created by using this constructor. So for this object right here, this refers to this object. For this object, this refers to this object. So for this object, this.x is equal to 100, this.y is equal to 200, this.r is equal to 20, and so on. And for the second object, this.x is equal to 200, this.y is equal to 400, this.r is equal to 60, and this.color is equal to yellow. So I think you get the idea. And now we can use this when creating methods, for example, to always refer to the object. So I can, for example, create a draw method that we'll use to now draw this circle, like so. And let me just console.log this.color, for example, for you. And now we're just going to call circle1.draw, for example, so the draw method. Let me inspect, so right click, inspect, and you can see we're getting white. So for our circle1.draw, so this color is going to be white because that was the color that we've passed. And for circle2.draw, we should get yellow because yellow is the color for our second circle. So I think you get the idea. We now have a method that behaves different for every single object. So let me close this. And now let's actually draw something onto our screen. So instead of just console.logging this.color, we can actually just do the stuff that we've done previously. So we're going to begin a new path for every single circle. So ctx.begin path, like so. We want to set the color, so the stroke style, to the color that we've passed right here. So ctx.stroke style is going to be equal to this.color, like so. Now we want to create our circle. So let's say ctx.arc. We have to pass x value. X value is this.x. Y value, this.y. Radius, this.r. Starting angle is going to be 0 for every single circle. So I'll just hardcode that one. End angle is going to be 2 times math.pi. Because all my circles should just be perfect circles, so that is fine. And counterclockwise is going to be false. And now I'll also say ctx.stroke right here. And you can see we now printed or drew our two circles. We drew our small circle and our big yellow circle. So I think you get the idea. By using objects, we can now easily create hundreds or thousands of objects by just using one single class blueprint. I could just create more and more circles over and over again. So I could create a third circle, 400, and so on. And now I could say circle3.draw. Doesn't matter, you get the idea. But maybe that's not what I want to do. Maybe I want to create hundreds or thousands of circles, and writing this out 1000 times would probably be really repetitive. So I'm actually not going to do that. Instead, I'll use a for loop. So let me define a for loop. So I could say for, I'll initialize a variable I, for example, so let I be equal to 0. I'm going to repeat a task as long as I is less than 100, for example. And I'm going to increment I by 1 for every single iteration, or after every single iteration. And for now, let me just create a new circle every single iteration. So I'll just say const circle is equal to new circle. And now I need to insert a couple of values right here. So of course I could hardcode those values. So I could say 100, 100, 30, and yellow, for example, like so. And now I could just call circle.draw. And you can see this would be an option, but we're not seeing more than one circle because at the moment all of those circles are stacking. So we'll draw all of those 100 circles on top of each other. So we somehow need to be able to get those values right here randomly. So let me start to create an x value. So const random x, for example, could be the variable name. And let's say this here is going to be equal to math, like so, dot random. Math.random will create a value between 0 and 1. So let me actually show you. Let me save this. Let me use this as an x value, like so. And at the moment, we cannot really see anything because, of course, a gap between those circles of 1 is probably not enough. If I would scale that one by 100, for example, though, you can see that we're now getting an offset. Because now we're getting a value between 0 and 1, so probably 0.5, 0.4, 0.2, and so on. And then we scale 0.2, for example, by 100, which would give us 20. We would also scale a circle with 0.9, for example, which would have an x value of 90 then, for example, and so on. So I think you get the idea. But of course, we want to display our values within our entire canvas. So we should say times canvas.width, like so. And you can see now our circles are essentially everywhere. They are spanning over our entire canvas. Because imagine if we're getting a value of 1, for example, for math.random, times the canvas width, which could be, for example, 700 at the moment, then we say 1 times 700. So we draw a circle right here at the end. If we're getting 0, for example, for math.random, then we say essentially 0 times 700, and we get a circle right here at the left. And everything is essentially in between. So 0.5 for math.random would essentially give us a circle right here. So that is how this works. But essentially, random x always defines the center of a circle. So let me show you. So at the moment, we're essentially saying that the center of a circle, for example, if you have math.random of 0, is going to be right here. So this is now the center of our circle. But now our circle also has a radius. So once we draw it around the center. So right here. And of course, we then have this overflow right here. Because our circle starts at the absolute left of the screen, but the circle itself, because of the radius, goes outside of the screen. So in order to fix that, we could say that we want to use math.random times the canvas width, but we don't want to go to the absolute end of our canvas. We actually want to stop one radius before the end, so we are never getting outside, and we want to start one radius after the beginning. So we'll always just add one radius to the beginning, so we just say that we'll add a radius. So let's create a radius variable, so const radius is going to be equal to 30 for now. So let's just hard code this, and let's say random radius, for example. So random radius is going to be equal to 30. Now we'll pass random radius to our circle right here as a variable, and we just add random radius right here. And you can see no circle right now goes outside of the image, but we have a lot of them going outside of the right of our image. So in order to fix that, we could say that we subtract radius or our random radius from our canvas width, like so minus random radius. But actually we should subtract our random radius twice. And the reason for this is that we'll add it once later on anyways. So let me draw this for you because this can be a little bit confusing. So we're saying take up all of the canvas width essentially, like so. So that is the canvas.width at the moment. Now we're going to subtract our radius, so the radius of the circle twice. So we're getting here and here essentially. So those are two radiuses at the moment. So we subtract that. So we only draw at this point in time our circles from this point to this point. So essentially at this point in time, the last circle will be here. But the first circle will probably still be right here. So we also add random.radius afterwards. So the first circle will now be here because we added random radius again. And the last one will now be here because we also added random radius again. So that is what the formula actually does. So I hope you understand that. But now we can of course also randomly generate our random radius, and we should also do so if we want to use a random radius. So we could just say math.random again, like so. And now we have all those small circles. So all of those circles now are between 0 and 1. But we could also scale it. So we could scale it by 30, for example. And now if we go at a small math.random value, we will have a small circle or a small circle radius. Otherwise, we will have a pretty big circle radius. And this formula right here ensures that our radius will always be on screen, no matter the radius. But now we can do the exact same for our y value. So let's do that. Let's create a variable const random y, which is going to be equal to math.random again. And again, let's multiply that with our canvas dot height in this case, because we want to have them on our y-axis. So the height is important here. And now let's also use minus 2 times random radius plus random radius. So the principle right here is essentially the exact same. And now we can use random x instead of hard coding 100 right here. And you can see now we have all of those circles on our screen. Now we could of course also create our color randomly, for example. And let me show you how this works. We could, for example, create a colors array. So const colors is equal, and this will store a couple of random colors. So maybe yellow, maybe white, maybe blue, and maybe red. And this right here will actually look terrible, but you'll get how this works in a second. And now we want to access an element of this array. And if you know about JavaScript, we could access the first element, for example, by saying colors of 0. The second one by saying colors of 1. The third one by saying colors of 2. And the last one by saying colors of 3. If we would now, for example, just use the length, so colors dot length, we will get the value 4. So this here is going to be equal to 4. if we would now use math.random, for example, we get a value between 0 and 1. And if we now multiply math.random with our colors.length, we will get a value between 0 and 4. But actually, math.random will give us a value between 0 and 1, but 1 excluded. So we'll never get 1. And therefore, if we're going to multiply the highest value, which is going to be something like 0.99, with 4, we will get something like 3.96, for example. So that will be our highest value. And if we are just going to use math.floor now to round it down, we will always get a value between 0 and 3, randomly essentially. So I hope you get the idea. So now we take math.floor of math.random, so a random number between 0 and 1, but 1 excluded. And now we'll multiply that with our colors.length essentially. And now we'll always get a value between 0 and 3. And now we could, for example, access colors of this random value right here. So we could just use this right here and put it in here. And now let me console.log this color for you. So console.log that right here, like so. Let's go to inspect. And you can see we're getting blue. Let me reload. White, yellow, and so on. And if we now do this for every single iteration, we'll get a random color every single time. So I could just say const random color is equal to this right here. And then I use random color instead of yellow. So let me actually save this random color. And you can see we have all of those random colors. And of course, you could also use like nicer colors right here. But you get the idea. Let's now understand animations. And let's just delete all of this right here. Because I think you understand it a little bit better if we get started from scratch. Like so. So we only have our canvas and our context at this point. Now I first want to create a circle so we can animate that circle. So let's create a circle. And let's not use a class at this point. Let's just create a basic circle. So ctx dot, and let's use a fill style because we want to have a filled circle. So fill style is equal to white. Now ctx dot begin path, like so, to begin a new path. And let's now use a circle. So ctx dot arc. For x, let's have 100, y 100, radius 20, for example, start angle 0, end angle math dot pi times 2, for example, and counterclockwise is false. And now let's just draw that one. So ctx dot fill, like so. So now we're having the circle right here. And now I also want to animate that circle. So let's create the animation. To animate that one, we could create a function, and that one could have the name animate, like so. And now within this function, we are going to call request animation frame, like so. And that one is a built-in function. And that one expects a callback, and we'll pass our animate function to that callback. So how does this work? We are now going to call the animate function right here. That one says execute whatever we have within this animate function. Within this animate function, we are going to call this method right here. And within this method, we'll have our animate function as an argument. And this method right here will now again call the animate function. So we call this function again. This function will again call this function, which will again call this function, which will again call this function. So you can see we have an endless loop right here. So let's, for example, just console.log, hey, let me go to the console. And you can see we're getting hey over and over again. So this is basically going to print this forever until we close this page. And this is great because now we can animate that one for every single tick. So every single tick, for example, we could change the position of this circle right here. So let's try this. So within this animate method, let's, for example, just create a new circle every time. So let's say ctx.begin path, like so. We're going to create a circle. So ctx.arc, let's use 100, 100, 20, 0, math.pi times 2, for example, and false. And now let's just use ctx.fill. And this will now draw our circle over and over again. And you see this one looks pretty weird already. But it's not really moving at this point in time because we just draw the same circle all of the time. But now we could, of course, also have a variable. So let x position be equal to 100, for example. So by default, x position is now 100. But now after every single iteration, we could just say x position plus equals 1. So we just increment x position by 1. And you can see now our circle essentially starts to move to the right. But this here still looks pretty weird because we never delete our old circle. So our old circle will always be there. And in order to clear the old circle, so clear whatever we had before, we can use ctx.clear rect, for example. This will clear the entire canvas. We need to define an x coordinate and a y coordinate, and this is usually 0, 0. And then for the width and the height, you just use the canvas width and the canvas height because you want to clear the entire canvas. So canvas.width and canvas.height, for example. And you can see now our circle moves from left to right. And after every single frame, we are first of all clearing the old frame, and then we are going to draw a new circle. So this is how this works. At the moment, I don't really like this animation though. And I don't really like the fact that we're using create right here without a class. So I'm going to change that first. So let's create a class circle. And since we already know how this works, I'm going to go over this a little bit faster. We first need our constructor. We want to have x. We want to have y. We want to have a radius. And that should be it for now. So let's say this.x is going to be x. This.y is going to be y. And this.r is going to be r. And now we want to draw our circle. So let's define a draw method right here. And we're just going to say ctx.begin path like so. We want to create a circle. So ctx.arc. As next value, we want to use this.x, y, this.y, radius, this.r, start angle is going to be 0, end angle is going to be 2 times math.pi, and this is going to be false. And now we'll just say ctx.fill, like so. Now I'm going to create a new circle, so const circle is equal to new circle. I want to use 100 for x, 100 for y, radius 20, and that should be it. And now within our animate method, I can just use circle.draw, like so. At the moment, we're not seeing our circle because our circle does not have a color. And now, of course, I could just say that ctx.fill style is going to be equal to white, like so. But since we'll have a lot of circles later on, and all of them will have the same color, for now I could just say that ctx.fill style is going to be white, and I'll just define it right here for all of the upcoming circles, like so essentially. So let's move this down, so this looks a little bit better, and this is the effect that we're having. But now I also want to update our circle every time we essentially animate it. So I'm going to create an update method, so update. And that one is essentially responsible for moving our circle. And this could be the variable name x movement, y movement, and so on. But usually you also just say dx and dy for movement into the x direction and movement into the y direction. And now, of course, we need to say this.dx is going to be equal to dx, and this.dy is going to be equal to dy, like so. And now we need to say that we want to move our circle into the x direction by dx every single time we call our animate method, and into the y direction by dy every time we call our animate method as well. So we could just say that this.x will be equal to this.x plus dx. So plus equals dx, for example. So this.dx. And the same for y. So this.y is going to be equal to this.y plus this.dy. So this is the movement speed essentially, and this here is the position. Let me save this, and let's also say 4 and 4, for example. And now we also need to call the update method. So we could say circle.update, like so. And you can see our circle is now moving. Let me decrement the speed right here, and you can see we're having this slowly moving circle. So just to make this clear, this.x will always hold the position, the x position, and this.dx will always hold the speed at which we change the x position. And the same, of course, for the y-axis. And of course, it's not mandatory to have this.x and this.y. You could also only change this.y or only change this.x. Like so, we would only change this.y. And like so, we would only change this .x, so the x position. So that is up to you. And of course, you could also define pretty much any logic you like right here, and all of this would be fine. But now I also want to show you how you can make this circle bounce off the edges, because at the moment it's just going to the right bottom, and at some point it just leaves the screen essentially. So how could we change this? We could, for example, check if our x position is currently below our screen height. So let me demonstrate that. So this here is the entire height of our canvas, for example. And now we are slowly but surely moving our ball to the bottom. And we could, for example, say if this .y in this case, so if the y position of our ball is greater, so if this right here, this position from top to our ball is greater than our canvas height, then we're obviously outside of our canvas. And under those circumstances, we want to bounce off essentially. What does bounce off mean? This just means that we reverse the speed essentially. So at this point in time, our speed essentially goes to the bottom. So we're moving to the bottom by 1 pixel every single time we call this animate method. And if we reverse this dx or dy variables for x and y, then of course we will go into the opposite direction like so. So I hope you get the idea. But let me show you how this works in code. We could first say, or we could first check if this .x, for example, or this .y, doesn't matter, it works the same for both directions. So if this .x is greater or equal to canvas dot, and for the x-axis, of course, we should use the width, so canvas dot width. If that is the case, then we're going to inverse this .dx. So this .dx is going to be equal to minus this .dx. So let me save this. And you can see our circle slowly moves to the right. And now it should actually at some point bounce off. And now we could do the exact same for our y-axis. So if this .y is greater or equal to canvas.height under those circumstances, because we are referring to the y-axis, then we want to say this .dy is equal to minus this .dy, like so. Let me also increase the speed a little bit because this is like really slow. And you can see now it starts to bounce off. But we still have the same problem at the left and at the top. Because of course, at the left, this .x is going to be 0 or less than 0 essentially. And at the top, this .y is going to be 0 or less than 0. So we should also check whether this .x is less or equal to 0, because then we also want to reverse the direction. So this .x is less or equal to 0, for example. And of course, the same should work for our y-axis. So we should also say, or this .y is less or equal to 0 as well. And now it should always bounce off. So what we're essentially saying right now with the first statement is, if our x position, so the position of our center of the ball right here, for example, is greater than the width of our canvas, so greater than this essentially, then we change the movement direction from there, so from downwards to upwards. Next up, by using the second statement, we are essentially saying if our ball, so if our ball, for example, sits right here and is less or equal to 0, so if that is the case, then we're also going to reverse the direction from essentially here to here. So from upwards to downwards. And of course the same goes for the y-axis. But now something that is important is that x and y always refer to the center of our ball. But as you can see, it still looks as if the ball slightly goes out. And the reason for this is that, of course, we only check for our center. But actually we should probably reverse the direction once our center plus the radius hits an edge. So if our ball essentially is sitting right here, we then already want to reverse the direction. And in order to do so, we can just subtract the radius, so this .r, from our canvas width. And of course the same goes for the height. So right here we can just do the same, and this works as well. And you can see this works for the side, but this does not work for left and top at the moment. So right here we still have this problem, because of course this is less than 0. So we should actually just say once this becomes less or equal to this .r, we also want to reverse. So let me replace that. So we should also reverse this, and now we should get the right effect. And of course the reason for this is that once essentially our point gets to this point, and only the radius is essentially left to the side, then we want to reverse the direction. So I hope you understand the idea. And now, of course, that we have this, we could also use multiple balls and create as many as we like. And in order to do so, we can, for example, create an array. So let circles be equal to an empty array for now. And now we want to use a for loop to create a lot of different circles. So for let I be equal to 0, as long as I is less than 100, for example, we want to increment I by 1, like so. And for every single iteration, we want to create a new circle. And we want to store the circle inside of the circles array. So let's say const circle is equal to new circle, like so. And of course, we need values like x, y, dx, dy, and r. And I can again randomly generate those numbers within a certain range. So now let's just randomly generate all of those values within a certain span. So first we need an x value. So const random x, for example, is equal to math.random. And again, we want to have those values. So we want to have our x value within our canvas. So again, we say times canvas.width, like so. But again, we have to say canvas.width minus 2 times our radius. We don't have our radius yet. So let's say const random r is going to be equal. And let's just use math.random. And let's have a radius between 0 and 15, for example. And now we just say times random r. And let's also add random r. So just the same formula that we've previously used. And now, of course, the exact same for random y. So const random y is equal to math.random, like so, times, and right here we have to use canvas.height minus 2 times random r plus random r, like so. So now we have the x, the y, and the r value. We also want to generate the x and the y. So the speed on the x and the y axis. So let's say const random dx is equal to math.random. And let's keep this value within a range of 0 to 5, for example. So 0 would be the slowest and 5 would be the fastest. Const random dy could be the exact same. So math.random times 5, for example. And now let's just use all of those values for a circle. So random x, random y, random dx, random dy, random r, like so. So this here is a circle now. And now let's just push this circle into our array. So circles dot push, and we push a circle into the circles array. And now after we've executed this entire queue, let me just console.log the circles for you so you understand how this looks. Let's go to our console, and we are getting the error circle is not defined. So actually we just need to remove them right here, like so. And now you can see we're having this array of circles. So all of those circle objects. And you can see we're having x, dx, dy, and so on. But we're actually getting not a number for a lot of them. And the reason for this is that this here is of course a function, so we should also call that. And now let me look at this again, and now we're having numbers for all of those values. So dx, dy, r, x, and y. So every single circle has those values. And those circles are random within a certain range, essentially. And range is of course the range that we've defined right here by using those scalars. And now we can just go over this array right here within our animate method and just draw and update every single circle right here. So every single one of those circles for every single tick of this animate function. So circles dot for each, we are getting one circle for every single iteration. And now for every single circle, we can just call circle dot draw and circle dot update, for example, like so. And now you can see we're getting all of those effects right here. So all of those circles who have all different sizes are moving on our screen. And I think this here is already a pretty cool effect. Now a problem that you might spot is that right here at the beginning, all circles move into the exact same direction. And therefore for a short time it looks pretty weird until everything is basically stable. But we can also fix that. And the reason for this is, of course, that by default, random dx and random dy is always positive. So how could we fix this? If you think about math.random, it will generate a value between 0 and 1. So now I could just go ahead and say math.random within brackets minus 0.5. And why would this work? Let me also do the exact same for dx. So minus 0.5. And you can see now this looks perfectly random. And the reason why this works is that if you get a number of 0, for example, this is going to be minus 0.5 times 5 minus 2.5. If you get a value of 1, then you would get a value of 0.5. So by using minus 0.5, this does not go from 0 to 1 anymore, but this instead goes from minus 0.5 to 0.5. Because if you get math.random of 1, minus 0.5, you get 0.5. And if you get math.random of 0, minus 0.5, you get minus 0.5. So this also alters the direction essentially. But now we still have one more problem. And the problem is that once we resize, so once we open our browser, you can still see we still have the same canvas width. And the reason for this is that only when we reload our entire page, only then the canvas will get the entire width and height of our window, because only then we are executing this file right here, and therefore setting the canvas width and height. But we can change that by, for example, saying that we first of all want to respawn our circles every time we resize the window, and we also want to reset canvas.width and height every time we resize the window. And actually there exists an event listener in order to do so. So we can just go ahead and say that we'll add an event listener to our window object, so window.add event listener. We want to call this event listener every time we resize our window, so every time the user essentially resizes his browser window. And under those circumstances, we want to call a callback function, for example. And within this callback function, I'd like to initialize the circles and the browser width. So I'm just going to say that I create a function, so const init being equal to this entire for loop here, for example. So let me just copy and paste this in here. So this for loop will essentially initialize all of the circles once we call it. So let me call it right here before animating, so init. So I can see this initializes now all of the circles. But now every time I call this init method, I also want to say that canvas.width is going to be equal to window.innerWidth, and canvas.height is equal to window.innerHeight, like so. So now every time I resize the window, the canvas should take up all of the available space. And in order to do so, we need to call the init method every time right here when the user resets or resizes his browser, so init, like so. And you can see now when I'm going to resize the browser, we have the same effect, so this still works. But we also see a problem, so let me show you. Right here, every time I resize the browser, we're going to call the init method again, and we get more and more circles. So let me do this a couple of times, and I think you already get the idea. We're getting more and more circles because we're not deleting the old circles, but we're always adding new circles by calling this for loop here once again. And of course, one of the possible solutions would be to just take this for loop and place it outside of this init method. And now we still would have the same effect. But you can see this here looks weird. So once I resize the browser, it takes a little bit of time for all of the circles to go over and take up all of the available space. So maybe you want that, and then that is fine. But maybe you also want to immediately resize or respawn all of the circles, and then that is of course not fine. So in order to fix that, you can just, when calling init, so when resizing essentially, also reinitialize all of the circles. But before doing so, we just set circles to an empty array. So we clear all of the old circles and then generate all of the new circles. And now, every time I resize the browser, we're just calling init again and therefore generating new circles that will spawn according to the new browser or canvas width and height essentially. So now let me introduce you to gravity. And in our case, we want to create gravity for a square, for example. So we want to have a falling square that hits the ground, bounces off, but obviously gets faster towards the bottom and gets slower towards the top. So similar to a normal ball that falls on the ground. So I think you get the idea. But let's use a square to also practice how to use squares. So let's create a class. square, for example, like so. We want to have a constructor. This constructor could have an x coordinate, a y coordinate, maybe also a falling speed that defines the speed at which our square falls. We want to have a width for our square and a height for our square. And now let's just say this dot x is equal to x, this dot y is equal to y, this dot falling speed is equal to falling speed, this dot width is equal to width, and this dot height is equal to height, like so. And now, of course, we also want to draw our square. So let's create a draw method for this. So draw, like this. Let's first of all set the style, so the fill style. So ctx.fill style is going to be equal to white. And now let's also draw our square. So ctx.fill rect. We are going to start at an x value of this dot x, y value, this dot y, w is going to be this dot width, and height is going to be this dot height, like so. And now we can just create a new square and test this. So const square is equal to new square. For the x value, let's just use 100, y 100. Falling speed could be 10, doesn't matter too much at this point. Width is going to be 50 and height 50, for example, like this. So let's save this. Let's also call square.draw to draw our square onto the canvas. And this is now our square. Now, of course, I would also like to animate the square. So I need to create an animate function. Const animate is going to be equal to an arrow function for now. And inside of this arrow function, we are going to call request animation frame. And within this request animation frame function, we call as a callback function our animate function right here, like this. And now, of course, afterwards, we should also call animate to execute it. And then this here will go on forever and ever. So just normal animation logic. Of course, we should also create an update method right now that we can call within this animate function. So update, like so. And right here, we want to move our y value by our falling speed. So let's just say this dot y plus equal this dot falling speed. And now within this animate function, let's first of all call our update method right here for our square. So for square dot update, and also the draw method afterwards. So I can just copy this line and paste it in here, like this. And you can see now our square is essentially moving at a constant pace. So this is pretty similar to all we had before. We should also clear everything we had before. So we could just say ctx.clear rect. We're going to clear and start at x of 0, y of 0. We clear for a width of canvas.width and a height of canvas.height, like this. And now we have a falling square. But now we also want to check if our square hits the ground. And if that is the case, then we want to reverse the movement. So within our update method, let's also check if this dot y is greater than our canvas height right here. So canvas dot height. And actually we need to subtract our height. So minus this dot height. So the height of our rectangle. And I'll explain why this works like this in a second. But first of all, under those circumstances, of course, we want to say this dot falling speed is equal to minus this dot falling speed. So we want to reverse our falling speed. And you can see now it bounces off. But let me draw for you why this works. So at the moment, let's imagine that our square is right here, for example. For a square, this dot y refers to the top left corner. And now we're checking if this dot y, so if this point, is essentially greater than our canvas height. So essentially right below our canvas. But now we subtract the height of our square, so essentially this height, from our canvas. And by doing so, we basically say our canvas does not really stop at the bottom, but instead the canvas should already end right here. Or at least the reference point for our square should end right here. So once this point essentially hits this line, we want to reverse the movement. So that is how this works. So pretty similar to the circle, but just a different reference point. But now I also want to increase the speed when falling. So I want to say that after every single iteration, I want to increase the falling speed. So this dot falling speed plus equals 1, for example. And you can see, now we already have this gravity effect. And let me first of all console log this .falling speed for you, so you really understand why this here works the way it does. So this .falling speed like so. Let's go to the console, so inspect, console, and you can see we have all of those numbers right here. And let me actually show you how this works. So we're starting at a falling speed of 10. We go to 11, 12, 13, 14, 15, all the way up to a max falling speed of 40. Then we're going to invert the falling speed, because we're saying this .falling speed is minus this .falling speed once we hit the bottom. And of course we are then at minus 39. And of course adding 1 to a negative falling speed will then increase the number, and at a certain point we get to a falling speed of 0 essentially. And once we switch from minus 1 to 1, we essentially automatically invert the movement direction. And that is essentially the point when we are going from our highest point, so from this point, back to our lowest point. So when we essentially change the movement direction. So now you probably might wonder why our square goes lower and lower, and at some point also might bug in the ground like this. So this is a problem that we can fix in a second, and I'll explain the reason to you for this. If you think about what we had previously, it's also possible that our square is sitting right here, for example. So it's essentially close to the bottom, but it's currently not really at the bottom. But during the next frame, it could be right here, for example, because we add falling speed right here to our y value. And we're going to check for this condition. For the previous frame, so for this square right here, this condition was false, so we are not going to invert the falling speed. And for this square right here, this condition is obviously true, because it's already outside of our canvas. So now we are going to reverse the falling speed. But now for the next frame, it would be possible that our square is a lot higher already, but it's still probably outside of the canvas, even though just slightly maybe. And then we're going to invert the falling speed once again, and of course this is going to bug once again. And of course this here would be a bug, because we do not want to invert the falling speed twice in a row, and doesn't make too much sense. And of course this here is more likely to happen once the falling speed is very, very little. And that's also the reason why this here usually happens at the end. So if I'm going to do this again, this will usually not happen in the beginning, but rather in the end. But of course this is nothing that we want. So every time we invert the falling speed, we also want to set this .y equal to the absolute bottom essentially. So we move it to this line right here. Even if it's further down, we move it back up to the line, and then we start to adjust this .y. So we can just say this .y is equal to our canvas height essentially. But if I would do this, our point would essentially start at the bottom, so our square would be outside of the frame. So in order to fix this, I should again subtract this .height, so the height of our square, and now this should fix the problem. And you can see it now does. Our square goes on forever and ever, and always ends at the exact same height. And of course we're going to increase our falling speed up to the lowest point. It's still going to be pretty high once we invert the falling speed at the bottom, but it's going to get gradually slower until we hit a falling speed of 0. And then we're going to invert the falling speed again, because we're adding +1 every time, and we're going back down. And of course we're starting slow and getting faster again. But now maybe we also want to make this here fall a little bit slower every time this here hits the ground. So we could also invert the falling speed and just add friction, for example. Doesn't matter how you call this, but friction would essentially reduce the height of a jump every time it hits the ground. So we could say friction of 0.1. So const friction is going to be equal to 0.8. And now this here jumps less and less every time it hits the ground. And of course you could also use 0.9. And then this would jump a little bit longer, but you get the idea, I think. And of course using this value is up to you. And that is pretty much all you really need to know to understand how to use gravity with JavaScript and HTML Canvas.